Hello, fellow viewers. This is Prof. 1 Tutorials. My name is Alfred Amprofi, and I'm here again to look at differentiation from the first principle. Differentiation from the first principle. When we talk about differentiation from the first principle, we have some notations we are going to look at. So let's look at those notations quickly. In Lebanese notation, we have dy over dx, which is equal to limit as di x approaches 0. In a big bracket, we have f of x plus di x minus f of x all over di x. This is Lebanese. Now we also have the functional notation. In functional notation, we have f prime of x is equal to limit as di x approaches 0, f of x plus di x minus f of x all over di x. Now, the di x that we have here is the same as h. So we can say that h is equal to di x. Simply, we can make substitution of h in the various notations. In that case, f prime of x is equal to limit as h approaches 0, f of x plus h minus f of x all over h. And don't forget that dy over dx we have here is the same as f prime of x. So dy over dx is equal to f prime of x. And we call them the differential coefficient. Differential coefficient. Now, the process of finding these differential coefficients is what we call differentiation from the first principle. So let's take some notes. The process of finding the differential coefficient is called differentiation from the first principle. So when you talk about differentiation from the first principle, it's basically talking about finding those differential coefficients, which is the f prime of x and then the dy over dx. So quickly, we are going to look at some few examples. Okay. Obtain from the first principle the derivative of A. F of x is equal to x squared. B. F of x is equal to 3x squared plus 3. C. F of x is equal to 2x cubed plus 4x minus 3. And you're going to look at how we can use the first principle in getting their derivatives. So let's start with the first one. F of x is equal to x squared. So if you are to find f prime of x, then from the first principle, limit as h approaches 0 in a big bracket, we have f of x plus h minus f of x all over h. We have f of x to be x squared. In that case, f of x plus h is going to be x plus h all squared. This means that wherever we see x, we are going to attach h to it. Now we need to expand this. In expanding this, I call it the SMS. SMS. The SMS we have here is just like you trying to send message to someone, right? Yeah. So the first S means we are going to square the first thing. So when I square x, I have x squared. The M here means multiplication. We are going to multiply everything we have here. We are going to multiply each term or each thing we have here. So x times h, we have xh times 2, we have 2xh. The last s we have there also means squared. So we are going to square the last term, we have h squared. So this will be our f of x plus h. In that case, I will substitute what I have here inside this. So f prime of x is equal to limit as h approaches 0 in a big bracket. The whole of this is the same as this. So we have x squared plus 2xh plus h squared minus f of x. And I have f of x to be x squared all over h. I still have f of x is equal to limit as h approaches 0. Then from here, this x squared can cancel this x squared. So it will be left with 2xh plus h squared all over h. All right. Now, when we get here, we are going to factor h out. So we have f prime of x is equal to limit as h approaches 0. Then when I factor h out, I have h into brackets 2x plus h all over the denominator h. This h will cancel the h. Then it will be left with limit as h approaches 0, then 2x plus h. The moment we talk about limit as h approaches 0, then the 0 will be substituted where we have h. So we have 2x plus 0. Then the answer is going to be 2x. So in using the first principle, at the end of the day, we are going to get 2x to be the final answer. Let's do a little recap. With a recap, this is the function. And we know that when we are differentiating from the normal perspective, when you differentiate x squared, the 2 will multiply the x, then difference 1, we still have 1, and we know that 2x power 1, we still have 2x. So this means that even if you use the first principle to differentiate, you have to get the same answer when you are differentiating from the normal perspective. Quickly, let's look at the second example. We have b. F of x is equal to 3x squared plus 3. 3x squared plus 3. So let's look at the solution from the first principle. We have f prime of x to be equal to limit as h approaches 0 in a big bracket, f of x plus h minus f of x all over h. So over here we have to get our f of x plus h. But f of x is equal to 3x squared plus 3. In that case, f of x plus h, anywhere we see x, we will attach h to it. So we have 3 into bracket x plus h all squared plus 3. Since this side is squared, we are still going to use the SMS. So we are going to square the x. We have x squared. Then I will multiply 1, 2, 3. I have 2xh. I will square the h. I have h squared plus 3. When I get here, I need to multiply through by 3. So I have 3x squared plus 6xh plus 3h squared plus 3 to be f of x plus h. Since I have this whole expression, I will substitute here so that we can continue with that. So in f prime of x is equal to limit as h approaches 0, I have f of x plus h, and that is the whole thing here. So I'll make substitution. So we have 3x squared plus 6xh plus 3h squared plus 3 minus brackets open f of x, which is equal to this whole thing, 3x squared plus 3. All over from here we have h. So all over h. Then you just close the bracket gently. Alright. Now in moving on, we still have limit as h approaches 0. And the negative here must affect everything in the bracket. So I still have 3x squared plus 6xh plus 3h squared plus 3. The negative affecting the minus 3x squared, we have negative 3x squared. The negative also affecting the 3, we have minus 3 all over h. Then we will close the bracket again. Minus 3x squared here can take off the positive 3x squared. Then positive 3 can also take off the minus 3. Okay, so we still have limit as h approaches 0. It will be left with 6xh here plus 3h squared all over h. When I get here, I have h here, another h here. This means that I can factor h out. Okay, so I have limit as h approaches 0, then h into bracket 6x plus 3h all over h. From here, this h can take off this h. So it will be left with what we have within the bracket. In view of that, I have f prime of x is equal to limit as h approaches 0, then I have 6x plus 3h. And we know that the moment h is approaching 0, it means that anywhere you see h, you substitute 0 over there. So we have 6x plus 3 multiplying 0. And it's going to be 6x plus 0 because 3 times 0 is still 0. Then our final answer for f prime of x is equal to 6x. Let's do a little recap. The question was f of x is equal to 3x squared plus 3. In differentiating from the normal perspective, the 2 here will multiply the 3. We have 6. Then you repeat the x. You take 1 from the exponent, we still have exponent 1. And when you differentiate 3, we are still going to get 0 because 3 is a constant. So over here, the final answer is still going to be 6x. So anytime you use the first principle or differentiation from the first principle, it should be equal to when you are differentiating from the normal perspective. Let's look at a third example. So we have f of x is equal to 2x cubed plus 4x minus 3. So from the first principle, we have f prime of x is equal to limit as h approaches 0 in a big bracket f of x plus h minus f of x all over h. So I have f of x is equal to 2x cubed plus 4x minus 3. So I need to get my f of x plus h. This means that anywhere I see x here, I will attach plus h to it. So it is going to be 2 into bracket x plus h cubed plus 4 into bracket x plus h minus 3. So this is going to be my f of x plus h. In that case, I need to expand this. So I have x plus h cubed. Don't forget it is the same as x plus h multiplying x plus h squared. So from here, x plus h, and we know that x plus h all squared from the same SMS. I will square my first term. I have x squared. The m means multiply this by this by this. So it is going to be 2xh plus, then the last s also means square the last term, which is h squared. After getting it, then you expand this whole bracket. So in expanding, x times x squared, let me bring it here. I still have x cubed. Then x times 2xh, I have 2x squared h. X times h squared, I have xh squared. Then I have h times x squared, I have x squared h. H times 2xh, I have 2x h squared. Then h times h squared, I have positive h cubed. So this will be x plus h all power 3. Now after getting it, then there is a need for us to make substitution here so that we can expand it by the 2. So I have f of x plus h is going to be 2 multiplying, it is going to be 2 multiplying x plus h cube, and this is my x plus h cube, so I must make substitution. I have x cube plus, and from here, before I write this, this is 2x squared h, and I have another x squared h. This means that 2x squared h plus x squared h, I am going to get 3x squared h. So 3x squared h plus, I have xh squared, another 2xh squared. When I put it together, I have 3xh squared. Then the last term is I have h cube. The last term is h cube. I have h cube. Then you close the bracket. Then I have 4 multiplying. So plus 4 multiplying x plus h. Then minus 3. When I get here, I will still expand this. So f of x plus h is going to be this by that. I have 2x cubed, 2 by this. I have 6x squared h, 2 times 3x h squared. I have 6x h squared. 2 times h cubed. I have 2h cubed plus 4 times x, I have 4x. 4 times h, I have 4h. Then my minus 3 will come. After getting your f of x plus h, it means that you can make substitution here. Don't forget that your f of x is still here, so you just make substitution in it. So f prime of x is equal to limit as h approaches 0. The whole of this is what we have here. So we have 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed plus 4x plus 4h minus 3 minus f of x, and this is my f of x. So minus bracket open, I have 2x cubed plus 4x minus 3 all over h. Then you close the bracket gently. After that, you have to evaluate them. So I still have limit as h approaches 0. Now, don't forget that the negative here must affect this, it must affect this, it must also affect this. So we have 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed plus 4x plus 4h minus 3. Negative affecting this, I have minus 2x cubed. Negative affecting this, minus 4x. Negative negative is positive 3. So in most cases we say nege nege. You can respond for me 4, right? Yes. All over h. After here, positive 2x cubed can take off the negative 2x cubed. Then positive 4x can also take off the negative 4x. Then I have negative 3 also taking off the positive 3. Now, from the first principle, in most cases, the f of x given must be cancelled out so that you can be able to simplify it very well. So we still have limit as h approaches 0. Then I still have 6x squared h, then plus 6x h squared plus 2h cubed plus 4h all over the h. then you close the bracket gently. Now when you get here, you must factor h out. So I still have limit as h approaches 0 in a big bracket. H is here, H is here, H is here, H is also here. So I can factor H out. So I have H into bracket 6x squared. So this H is off, plus 6xh. I have taken one of the H, plus 2h squared plus 4. You close the bracket, all over H. After factorizing, then there is a need to cancel out this and this. So from here, we still have limit as h approaches 0 in a big bracket. It is left with 6x squared plus 6xh plus 2h squared plus 4. Now from here, because limit or h is approaching 0, then anywhere I get h, I need to substitute 0 over there. So f prime of x is now equal to 6x squared plus 6x multiplying 0 plus 2 into bracket 0 squared plus 4. Then the final answer is going to be 6x squared. This whole thing will move 0. 2 times 0 squared is still 0 plus 4. Then finally, we have 6x squared plus 4 to be the final answer. Now, let's do a little recap. With a recap, the question was f of x is equal to 2x cubed plus 4x minus 3. This was the question. Differentiate from the differential from the normal perspective. We have f prime of x is equal to 3 times 2. We have 6. Difference one of the exponents we have squared. Then when you differentiate 4x, we have 4. But when you differentiate the negative 3, is going to be 0. Because negative 3 is a constant. So finally, the answer is going to be 6x squared plus 4. And that is the same thing we had here. So anytime you use differentiation from the first principle, you need to get the same answer when you differentiate from the normal perspective.